We've all seen the movie scene. A giant asteroid hurtles towards Earth, a colossal explosion, and then ... poof. The dinosaurs are gone. A clean, dramatic end. But what if I told you the end of the dinosaurs wasn't an instant event? What if some of them held on, fighting for survival in a world that had turned completely upside down? Today, we're diving deep into the aftermath of the Chicxulub impact and asking the fascinating question: how long did the dinosaurs actually survive after the asteroid hit? First, let's set the stage. About 66 million years ago, a rock the size of a mountain, traveling faster than a speeding bullet, slammed into what is now the Yucatan Peninsula in Mexico. The impact was unimaginably powerful, equivalent to billions of atomic bombs. The immediate effects were catastrophic. Anyone or anything within hundreds of miles of the impact zone was vaporized in a flash. Earthquakes greater than anything we've ever recorded would have shaken the entire planet. Mega tsunamis, hundreds of meters high, would have ripped across coastlines, washing far inland. But that was just the beginning. The real killer wasn't the initial blast, but the chain reaction it set off. The impact threw trillions of tons of dust, soot, and vaporized rock high into the atmosphere, creating a thick, dark blanket that enveloped the globe. This is what scientists call an impact winter. Sunlight was blocked, maybe for months, maybe even for a couple of years. Temperatures plummeted. Photosynthesis ground to a halt. Plants withered and died, from the giant ferns to the microscopic plankton in the oceans. This is where the true test of survival began. Without plants, the entire food web collapsed. The big plant-eating dinosaurs, the herbivores like Triceratops and Edmontosaurus, were the first to face starvation. They were huge animals that needed a constant, massive supply of vegetation. Within weeks or months of the impact, with their food source gone, they would have started dying off in droves. We find their fossils in the layers of rock right up to the impact boundary, but almost never above it. Their size, once their greatest advantage, became their fatal weakness. But with the herbivores gone, what about the carnivores? You might think the mighty T-Rex, the king of the dinosaurs, would have had a brief moment of feasting on the dead and dying herbivores. And that's probably true for a very short time. But that food supply would have run out quickly. Soon, the apex predators would have faced the same fate as their prey. Starvation. The bigger the carnivore, the more food it needed, and the faster it would have succumbed. A world without plants is a world without plant eaters, and a world without plant eaters is a world without large meat. It's a brutal but simple ecological cascade. So, are we talking about days, weeks, months? For the vast majority of non-avian dinosaurs, yes. Their demise would have been relatively swift, unfolding over a period of months to a few years. Think about it like a global famine combined with a never-ending, freezing cold night. The ecosystem was fundamentally broken, and there was nowhere for these large animals to hide. But here's where the story gets really interesting. The question isn't just about the giants, it's about non-avian dinosaurs. Could some smaller ones have held on for longer? This is a topic of intense scientific debate. Some evidence, though controversial, suggests that a few pockets of dinosaurs might have clung to life for much longer than we thought. This idea is known as the dead clade walking hypothesis. A clade is a group of organisms descended from a common ancestor. The idea is that even though the dinosaur clade was doomed, a few stragglers might have persisted in isolated pockets, like refugees in a post-apocalyptic world. What's the evidence for this? Well, it mainly comes down to fossils found in places and rock layers where we don't expect them. For example, there have been reports of dinosaur fossils found in the Paleocene, the geological epoch that began after the extinction event. These are often called Paleocene dinosaurs. These fossils are typically found in formations like the Hell Creek Formation in Montana, a famous hotspot for late Cretaceous fossils. How could this happen? The most common explanation is that these fossils are reworked. This means that a fossil from an older Cretaceous-era rock layer was eroded out by a river or a landslide, then washed downstream and reburied in younger Paleocene-era sediment. Imagine a dinosaur bone sitting in a 66-million-year-old riverbank. A million years later, a new river cuts into that bank, picks up the bone, and deposits it miles away with a bunch of newer sand and mud. To a geologist millions of years later, it looks like a dinosaur fossil in a post-dinosaur rock layer. Geologists have ways to test for this by looking at the wear and tear on the fossil and the surrounding geology, and in most cases reworking is the most likely answer. However, a few finds are harder to dismiss. Some researchers claim to have found fossils that appear to be in their original location or in situ within Paleocene rocks. If true, this would be groundbreaking. It would mean that at least some dinosaur populations survived the initial impact winter and lived on, perhaps for thousands of years. One study from the early 2000s described a hadrosaur or duck-billed dinosaur femur found in New Mexico that was dated to about 500,000 years after the main extinction event. This was huge news, but it was also met with a lot of skepticism from the wider scientific community. The challenge is always to definitively prove that the fossil wasn't reworked from older deposits. So, let's imagine a scenario where a small group of dinosaurs did survive. What would their world have been like? It would have been a fern spike world. After the initial darkness, the first plants to recover and dominate the landscape were hardy, opportunistic ferns. We see a massive spike in fern spores in the fossil record right after the impact. A small, resilient herbivore might have been able to survive on these ferns, and if there were herbivores, perhaps a small, adaptable carnivore could have survived by hunting them. These survivors wouldn't have been T. rexes or Triceratops. They would have been smaller. Perhaps animals that could burrow to escape the worst of the environmental chaos, or those with less specialized diets. But even for them, life would have been incredibly tough. The climate remained unstable for thousands of years, and they would have faced new competition from the rapidly evolving mammals that were beginning to fill the vacant ecological niches. Ultimately, even if a few pockets of non-avian dinosaurs survived for a few thousand or even a few 100,000 years, they were on borrowed time. The world had changed too much, too fast. They were the last embers of a fire that had already gone out. They couldn't compete in this new world, and eventually they too would have vanished, leaving no descendants. So, to answer our main question, how long did the dinosaurs survive? The vast majority of them, the giants we all know and love, were likely gone within months to a few short years after the impact. Their food supply vanished, and their massive bodies couldn't cope. But the possibility remains that a few hardy, lucky stragglers held on in isolated refuges for much longer, perhaps for thousands or even hundreds of thousands of years. They were the last of their kind, a dead clade walking in a world that no longer belonged to them. But let's not forget the most important part of this story. One group of dinosaurs did survive, and they didn't just survive, they thrived. We see them every single day. They are the birds. That's right, modern birds are the direct descendants of a specific lineage of feathered, two-legged theropod dinosaurs, much like the velociraptor's smaller cousins. They survived because they were small, had fast metabolisms, could fly to escape danger, and find scarce food, and many had beaks adapted for eating seeds, which were plentiful after the fires. So, in a very real sense, the dinosaurs never completely went away. Their reign as the dominant land animals ended 66 million years ago in a blaze of fire and a long, dark winter. But their legacy flies on in every sparrow, pigeon, and eagle we see today. The story of their end is not one of an instant disappearance, but a complex, brutal, and fascinating tale of collapse, survival, and ultimately, evolution. Thanks for joining me on this deep dive into one of history's greatest extinction events. What do you think? Do you believe some dinosaurs held on for a while? Let me know in the comments below. And if you enjoyed this journey back in time, be sure to like this video and subscribe for more adventures into the mysteries of our planet's past. See you next time.